Welcome to my channel. Today we are going to discuss about the objective type question from the part microwave semiconductor devices. So already I posted the 16 videos for the subject antenna and microwave engineering. So which is available in the playlist of my channel, antenna and microwave engineering playlist. Okay. And I will give the link for those videos in the description box also. If you want to study, you can use it. Okay. So the first question. So you see the operation of microwave bipolar transistor depends on dash transit time, PN junction thickness, transit time and PN junction thickness, depletion region, base width. So the operation of microwave, the bipolar transistor depends on the transit time and PN junction thickness as well as the depletion region. So based on these property, the microwave bipolar transistor, it works. Okay. So C is a correct answer. The next one, the microwave bipolar transistor is operated in which mode? Class A, Class B, Class AB, Class D. So Class B, the microwave bipolar transistor is operated in Class B mode. Okay. So option B is the correct one. The next thing, the operation of FET depends on dash. The operation of FET depends on varying conductivity of semiconductor material, transit time, frequency, pinch of voltage. The operation of FET in microwave depends on varying conductivity of the semiconductor material. Okay, this is the correct one. Then the next one, FET is used as dash. Oscillator, amplitude limiter, rectifier, switch. FET is used as an oscillator. So we can use FET is also as an amplifier. So here in that fourth thing, so which one is a correct means oscillator. So FET is used as an oscillator. Then the next one, the tunnel diode. So the tunnel diode and is a important microwave active devices. So tunnel diode is a positive resistance device, negative resistance device, passive device, rectifier. Tunnel diode, it is having the important property is that negative resistance region. So that's why the tunnel diode, it is called as a negative resistance device. So using this property, we can use this tunnel diode in a microwave applications. Okay. So the tunnel diode, it's a negative resistance device. Okay. Then the next one, tunnel diode is used as dash. Tunnel diode is used as oscillator, rectifier, low speed switch, clipper. Tunnel diode, it is useful as an oscillator. It is used to generate the microwave frequencies. So tunnel diode, because of the negative resistance property, it is used as an oscillator. It is used to generate the signals of high frequency. So tunnel diode, it is used as an oscillator. It's a correct thing. Then the next one, tunnel diode is high speed switch, clipper, low gain amplifier, low frequency oscillator. Already you know the tunnel diode, it is working as an oscillator, but it is not a low frequency oscillator. It is used to generate the microwave. Microwave means already you know in the range of gigahertz. Okay, so the tunnel diode, it is not used as a low frequency oscillator. It's not used as an amplifier. It's not used as a clipper. So ordinary PN junction diode, it is used as a clipper. Okay, application of PN junction diode is a clipper. So the last three thing is wrong. So the tunnel diode, it is used as a high speed switch also. Okay, so tunnel diode, it is mainly used to generate the microwave frequency because of negative resistance region, as well as the tunnel diode, it's working as a high speed switch. Okay, then the next one, in tunnel diode, the tunneling phenomenon is minority carrier effect, majority carrier effect, frequency effect, transit time effect. So in tunnel diode, it is working under the principle of tunneling phenomenon. So the tunneling phenomenon is because of which one means the majority carrier effect. So because of the majority carrier effect, the tunneling phenomenon is working. Okay. Then the next one, the tunnel diode is also called as dash. The tunnel diode, the other name of the tunnel diode, it is called as a Saki diode. Okay. So sometime, so the tunnel diode, it is also called as a Saki diode. So one of the question. Then the next one, the impurity concentration in tunnel diode is very high. So the statement is true or false? True. So the impurity concentration in tunnel diode is very high. Okay. Then the next one, the tunnel diode, it is used as amplifier and oscillator. Yes. Okay. Tunnel diode, it is used as an amplifier as well as oscillator. Then the next one. So these are all the questions about the tunnel diode. So you just see the tunnel diode. First one, the tunnel diode. It's a negative resistance device. Okay, that's the important thing. And a tunnel diode, it is useful as an oscillator. Microwave frequency generation, we are using the tunnel diode. So in this 4 option, oscillator is a correct one. Then this tunnel diode is also used as a high speed switch. Okay, and in tunnel diode, the tunneling phenomenon is based on the majority carrier effect. And what is the other name of tunnel diode means? It is a Esaki diode. And the impurity concentration in tunnel diode is very high. Okay. And we can use the tunnel diode as an amplifier and an oscillator. Okay. So it is used both amplifier as an oscillator. It's a true only. Then the next device, the next microwave device, TED. What is TED? The TED means transferred electron device. Okay. So the expansion of the TED, it's a transferred electron device. Then the TED has 2 junctions. It's a true or false? False. Okay. The TED has many junctions. It's not having 2 PN junction. It is having many junctions. So it's a false statement. Then the TED, the transferred electron device, is an dash device. It's a passive device or active device? Active device. Okay, the TED, it's an active device. That is the directional coupler, isolator, circulators we studied in the previous topic, you know. So that devices are microwave passive components. And this pin diode, Gunn diode, tunnel diode, this transferred electron device. So all these things are active devices. So TED, it's an example, it's a active device. Okay, active microwave device. Then the next one, the TED is used as switch, oscillator, clipper, rectifier. So TED, the transferred electron, one of the example for the TED is a Gunn diode. So Gunn diode, it is used as an oscillator. So TED, it is used as an oscillator, microwave oscillator. Then the next one, the TED is a negative resistance device, positive resistance device. TED is a negative resistance device. So similar to tunnel diode, in transferred electron devices also having the important property, it is the negative resistance device. Also in that BI characteristics, we can see the negative resistance property. Okay, so if you are increasing the voltage, the current, it will not increase in that position. The current, it will be decreasing. So that is that portion, it is called as a negative resistance region. So in TED, the main thing is said to be that the TED is a negative resistance device. Okay. The next one, the output power of TED is dash than that of BJT. So the transferred electron device, the output power of the transferred electron device is higher than the BJT. Okay, so bipolar junction transistor, compared to bipolar junction transistor, the output power of the transferred electron device is higher. Okay, higher. Then the next one, the example for the TED is. So which one is the transferred electron device? Which one is the example for transferred electron devices? FET, Gunn diode, tunnel diode, BARITT diode, Gunn diode. So Gunn diode is one of the example for the transferred electron device. Okay, or transferred electron device. The next one, Gunn diode is so already you know transferred electron device is having the property negative resistance property. So Gunn diode is a transferred electron device. So Gunn diode is a dash, negative resistance device, positive resistance device, high noise device, low frequency device. So Gunn diode is a negative resistance device. Okay, similar to tunnel diode, Gunn diode is also a negative resistance device. The next one, the Gunn diode is a low noise device, positive resistance device, high noise device, low frequency device. Gunn diode is a high frequency device. It is operating in microwave region. Okay, and Gunn diode is a negative resistance device. So these two options are wrong. Okay, B and D is a wrong answer. So either it's a low noise device, high noise device, it's a low noise device. So the noise produced in the Gunn diode is very less. So Gunn diode is a low noise device. And the Gunn diode is used as an oscillator. Yes. Okay, so we can use the Gunn diode in order to generate the microwave frequencies. So it is used as an oscillator. It's a correct answer. And the Gunn diode does not have any junction. It's a true or false? It's a true. The Gunn diode does not have any junction. The next one, the LSA diode is an example of dash. LSA. The LSA means the limited space charge accumulation device. So there is a one more category is the LSA device. LSA means limited space charge accumulation device. So this LSA diode is an example for what? TED, transferred electron device, PN diode, PNP diode, PNPN diode. So the LSA, it's an example for transferred electron device. So one of the category of TED is a LSA diode. Okay. Then the next one, LSA is a positive resistance device. It's a false. So already you know LSA, it's a one of the category of TED, transferred electron device. So already you know the transferred electron device is a negative resistance device. So LSA, it's not a positive resistance device. Okay, so the statement is false. It's a negative resistance device. The next one, LSA provides high power output. It's a true or false? Okay, true. So the LSA, it provides the high power output. Next one, impact diode. Okay, so the next diode, we are going to see about the impact diode. So the second diode we discussed, it is a TED. TED means transferred electron device. It's a negative resistance device. The example, the output power of the TED is very high when compared to BJT. And the example for the TED is Gunn diode. So Gunn diode, it is also a negative resistance device. And the Gunn diode is a low noise device. Okay, that's a very important thing. It produces very low noise. And the Gunn diode, we can use similar to tunnel diode. Gunn diode, it is also used as an oscillator. Okay, and next one, LSA. LSA diode is an example for the transferred electron device. That's why the LSA, it is a negative resistance device, not a positive resistance device. So the abbreviation of LSA is limited space charge accumulation device. And this LSA provides high power output. Okay, so these are all the things about the second diode, TED. TED example is Gunn diode. So the next microwave diode, it is a impact diode. Okay, the next semiconductor device, microwave semiconductor device, it's a impact diode. So impact diode is an avalanche transit time device, low frequency device, high efficiency device used as a switch. So impact diode is an avalanche transit time device. Avalanche transit time device, impact diode. And next one, the impact diode is narrow band device, wide band device, noiseless device, low frequency device. So impact diode is a wide band device. Impact diode, it is used as a wide band. It is a wide band device used for a very high frequency range. And next one, the impact diode is a noisy device. It's a true or false? True. Okay. The Gunn diode, it's a very low noise device. But this impact diode, it's a noisy device. Okay. It produces very high noise, a high amount of noise. So impact diode is a noisy device. It's a true only. And impact diode is used up to 100 gigahertz. It's a true or false? True. So that impact diode, it can used in microwave frequency. So up to 100 gigahertz, we can use this impact diode. Then the next one, the impact diode is used as an amplifier. Yes, okay, it is used as an amplifier. And impact diode is popular in digital communication system. Yes, okay, it is also true. The impact diode is used in digital communication system. So these are all the questions about the impact diode. So impact diode, it's a avalanche transit time. Impact diode is an avalanche transit time device. Impact diode is a wide band device, and impact diode is a noisy device. Okay, that is used up to 100 gigahertz. This impact diode is used up to 100 gigahertz. This impact diode is used as an amplifier, and this diode is popular in digital communication system. Okay, so these are all the questions about impact diode. So the next diode, TRAPATT diode. So this TRAPATT diode, it is also a important semiconductor devices used in microwave. Okay, TRAPATT diode means the TRAPATT. The expansion is trapped plasma avalanche triggered transit diode. trapped plasma avalanche triggered transit diode. Okay, and the TRAPATT diode is high efficiency diode oscillator. It's a true or false? It's a true. So TRAPATT diode, it's a high efficiency diode oscillator. Then the TRAPATT diode has which structure? P plus N plus structure, N plus P plus N structure, PNP structure, NPN structure. So the first one is correct. P plus N plus structure. P plus means the heavily doped P material, N type semiconductor, then N plus heavily doped N structure. So the TRAPATT diode, it has a P plus N plus structure. And the TRAPATT is high efficiency oscillator, low efficiency oscillator, switch rectifier. TRAPATT is a high efficiency oscillator. Okay, and the TRAPATT is used as local oscillator in radar, amplifier in radar, switch in communication transistor, low frequency oscillator. So the TRAPATT, it is mainly used in local oscillator in radar. So already you know the TRAPATT, it is used as a high frequency oscillator. Okay, so because of this thing, high efficiency oscillator, it is used in radar in local oscillator in order to generate that particular signal. In local oscillator, we are using this TRAPATT diode. Okay, the main application is that one. And the TRAPATT diode produces high power. So the power output produced by the TRAPATT diode is also very high. Okay, the next diode, it is a BARITT diode. So this BARITT diode, it is also one of the semiconductor devices. So the BARITT diode has which structure? P plus N, P plus structure. So this TRAPATT diode is having the structure is that, you see, P plus N plus. TRAPATT is P plus N plus. BARITT diode has P plus N, P plus structure. Okay, P plus N, P plus structure. Then the BARITT diode is a low noise oscillator, low power device, narrow band device, all of the above. All of the above. The BARITT diode, it's a low noise oscillator, low power device, narrow band device. Okay, but the TRAPATT is reverse. The TRAPATT is, you see, this TRAPATT is a high power device, high efficiency oscillator. Okay, but this BARITT is, it's a low noise oscillator, low power device, narrow band device. Okay, then the BARITT diode is a low noise oscillator. It's a true. Okay, it's a low noise oscillator. Similarly, BARITT diode is more useful as an amplifier. Yes, it is used as an more useful as an amplifier. Then the BARITT diode is a microwave device. It's a true or false? True. The BARITT diode, it is used as a microwave device. So the devices we will discuss in this thing, the tunnel diode, Gunn diode, the transferred electron device, then TRAPATT, BARITT, all devices are working under the microwave field. Okay, so all devices, these devices are microwave device only. So BARITT diode is a microwave device. Yes. Then the next one, which of the following is the biggest advantage of TRAPATT over IMPATT diode? Low noise, high efficiency, ability to operate at a high frequency, lesser sensitivity to harmonic. So the greatest, biggest advantage of the TRAPATT diode is high efficiency. So already we discussed, you know, the TRAPATT diode is, it is used as a high efficiency oscillator. Okay. So the biggest advantage of this TRAPATT diode is a high efficiency over this IMPATT diode. Then the next one, which of the following is the semiconductor diode which can be used in switching circuit at microwave range? Okay, pin diode. Okay, there is another one important device is there, semiconductor device in microwave, pin diode. So this pin diode means P type intrinsic, then N type semiconductor. So that is a pin diode. So this pin diode is mainly used in switching circuit in microwave range. Okay, pin diode. So pin diode is a dash, a metal semiconductor point contact diode, microwave mixture diode, often used as a microwave detector, suitable for use as a microwave switch. So microwave switch, this pin diode is mainly used, it is very suitable to use as a microwave switch. Okay, in high frequency, it is used as a high switch. Then the next one, the pin diode is dash. Pin diode is phase shifter, oscillator, rectifier, amplifier. So pin diode, it is also used as a phase shifter. So it is used as a switch also. Similarly, the pin diode, it is used as a phase shifter. In order to produce the phase shift, we can use this pin diode. Okay. Then the next one, the pin diode is used as an amplitude modulator. It's a true or false? True. So we can use this pin diode in order to use as an amplitude modulator in communication system. The next one, for what are the that is for what the pin diodes used in microwave: mixer, modulator, oscillator, amplifier. So the pin diode in microwave, the pin diode, it is used as a modulator. Okay, so already we discussed, you see, it is used as an amplitude modulator. So using pin diode, we can construct the modulator circuit. Then what is the other name of LSA diode? What is the other name of LSA diode? Negative resistance, bulk effect, tunneling effect, time space, bulk effect. The other name of the LSA diode is bulk effect. The next one, what is the advantage of LSA over a Gunn diode? More efficient, high power, less noise, high frequency, high power. When compared to the Gunn diode, this LSA device, LSA diode, it can produce the higher power. Okay, so that is the advantage of LSA. LSA is also a TED device, transferred electron device. Gunn diode is also a transferred electron device. But what is the advantage of LSA over Gunn diode? Means it produces the higher power. Okay, so these are all the some of the questions about the microwave semiconductor device. Okay, so in this video we discussed. So what are all the things we discussed? The first one is tunnel diode. Okay, so tunnel diode. What is the use of tunnel diode? What are the properties of tunnel diode? Tunnel diode is a negative resistance device. Okay, it is used as an oscillator. It is used in microwave range. Then the next device we discussed TED. TED means transferred electron device. One of the TED is a Gunn diode. So we discussed what are the important thing about the Gunn diode. Gunn diode is also a negative resistance device, low noise device. It is used as an oscillator. Then the LSA. LSA, it is also an example for TED. Another one example for the transferred, similar to Gunn diode. Another one example for TED is a LSA device. Okay, this LSA is also a negative resistance device. LSA produce high power output. That is the advantage of LSA over Gunn diode. Okay, the last question we discussed, you know, what is the advantage of LSA over Gunn diode? Means it produces the high power output. Okay, that is the thing. Then we discussed IMPATT diodes. Okay, IMPATT diode. Then BARITT diode. Okay, TRAPATT diode, BARITT diode, PIN diode. These are all the some of the important microwave semiconductor devices used in a field of microwave. Okay, so thanks for watching my channel, and please subscribe my channel for more videos, and please share this video to your friends also. We will meet in the next video. Thank you.